All right. 8-2. 8-2. You happy over there? Look, this guy's excited. We're doing some confidence intervals. Look at he's even got his arms spread out for confidence interval, like right from here to here. Sorry. That's what happens when Graham leaves his toys around. All right, and he goes to sleep. Dad just plays with them all night. All right, so we are getting at 8-2, and we're going to get a little bit more picky about how we're doing our confidence intervals. 8-1 was just kind of like a here it is, bleh, kind of. All right, you're not really going to be doing that easy. We're not going to give it to you that easy. It's not that hard though. So first of all, in AP Stats, we want to be exact as possible, and every decimal can mean very different results. Because of this, from now on, we must no longer use the empirical rule. Okay? So, we are not going to use 1, right? 95 and 99 points. So we're not going to do the, 1, 2 for a critical value, right? Because this would be 1 standard deviation, that's 2 standard deviations. That empirical rule is just an estimation. Okay? Just an estimation. We want exact. Alright? So how can we figure out the exact 68%? Alright? Well, let's just think this through. Okay. Alright. So 68% of my data. Alright? If I've got it in here in the middle. How much data is just over here? Because I could probably look that up on the chart, right? Well, 68% of the data is 1 deviation over, right? Because this would be 0. So at -1 deviation, that should kind of tell, alright. So, I don't know what I'm doing anymore. Alright. I'm looking for, let's see, 32%, alright? Is on both ends. Divide that by 2. That means 16% must be over here. Okay. Now I'm in the mood. All right. So 16% must be on this end, right? So I can look this up on the chart. Basically, I'm looking for when this is at 16%, right? All right. So I'm going to keep looking. I'm going to scavenge, try and figure out where is 16%. Well, it looks like it's between here and here. Which one's closer? It looks like at around 0.99. That looks like this is closer. This is only 11 away. That's 13 away. So 0.99 is actually 68%. So we were way off on an empirical rule, right? So instead of putting a 1 down, if we want 68% confident, we're going to put 0.99. Rarely do you ever say, I want to be 68% confident. Usually you want something more. You want like 90 or 95, right? So let's try and figure that out. Okay, so same situation. Okay, so sorry, this would be 0.99, right? That's really close to 1. Dreadfully close to 1. All right. Let's see, 95%, let's be really accurate, okay? So if I have 95% on the inside, how much is over here? And I'm hoping you guys can do this without doing the math. It's going to be 2.5%, correct? On that tail end. So I'm going to look on my chart, and I'm looking for 2.5, 0.25, boom! Nope, that's not it. Keep looking. 0.225, right there! Oh, look at that, that's a sweet spot. That's right in the middle. That is 1.9, right, 1.96 away. By the way, I have this one memorized. So the standard deviation means I'm 1.96 away from the center. So instead of putting a 2 down, we will no longer put a 2 down. We're going to put a 1.96. Okay? That's how they figure these out, right? Okay, now, just so you know, you will never have to do this because we have a really cool chart that tells us all these. But I think it's kind of nice to kind of go through and say, oh, that's where we're getting the numbers. Okay? So instead of putting a 1 for 68%, we're going to put 0.99. Instead of putting 95% confident, we're going to put a 2 for CV. No, we're going to put 1.96. It's more exact, a little bit more precise, a little more dainty. Okay? So, here's the cool thing. Alright? So, if you keep flipping through your yellow sheet, you're going to get to this page right here. It's called Table B. Why don't you take out your yellow sheet? Just look at the beauty that Table B provides. DF, you don't even know what DF stands for. You could make up an acronym for DF. Go for it. Somebody shout out an acronym. Oh, that's a good one. Okay. All right. But if you scroll all the way down, by the way, we'll learn this in 8.3. We'll learn what DF stands for. Don't worry, I'm not leaving this alone. Degrees of freedom. Oh, okay. If you scroll all the way down, you'll see this infinity sign, right? It's kind of like an infinity war that we're going to be waging. And notice down here, it also says confidence level or confidence value. And at 95%, look at this number right here. Oh, Billy me, Billy boy, Billy. Okay? So there we go. All right? That's it. So if they say, I want to be 95% accurate, and you want to know what CV value you're going to put in, you're going to be like, oh, I can't put a 2 anymore. So come to this page, check out 1.96. You should really memorize it because it's that important. We almost do everything is 95% confidence. What if you want to be 99% confident? That's the value you're going to put in. If you want to be 99% confident, you're somewhere between 2 and 3 standard deviations. And so you'll put in a 2.576. That's how many deviations out you'll go. Okay, cool? Sweet. Let's do some math. All right. You need blue and gold beads for a Michigan party you're throwing in the store. Sorry, you're throwing. In the store, you find a jar full of 13,000 beads. After looking at the bottom and counting the blue and gold beads, what is the confidence interval for the actual amount of blue and gold beads in the jar being 95% confident? All right. Man, there's so many options. All right, here's the bottom of our beads, okay? Now, I want blue and gold, so I'm only paying attention to blue and gold. We could count all the other percentages, but I really want to know blue and gold, right? Okay. So, I'm going to pause. I'm going to count how many blues and how many golds there are. And by the way, you guys have been at these party tricks before where you got to figure out how many are in the bag or whatever. I don't know. Okay. We're going to try and figure out the percentage of blue and gold in this whole container here. Watch out. Pause. We're back. Alright. So, I counted through all the colors because I figured I need a total sample. And I figured out I have 19 blue, 17 yellow. That's a total of 36 blue and gold. Cool. Alright. Now, after I total all of them up, I see there's 130. So my proportion of blue and yellow is 360 out of 130. Alright, we're going to start kicking this through. Let's see, divided by 130 is 0.2769. Alright, let's turn to the next page. Let's see what we actually got to do with this problem. Oh. What? Okay, well, I'm assuming we're going to do the 4-step process. So let me look at the notes quick. Yeah, that's what I thought. Okay, so our notes say 4-step process. So the 4-step process we're going to learn is called state, plan, do, conclude. All right, and from now on, when you do an inference problem, you're going to have to remember all of these. I'm going to write these out because we're going to run out of time if I don't. All right, so as I was saying, 4-step process, state, plan, do, conclude. we're going to have to fill out each one of these. Now, when we're doing confidence intervals, this is how it goes. And this is what we need to put for our state. First of all, statement. What are we actually going to be doing? And so I like to kind of copy down what the last couple words was. What is the confidence interval for the actual amount of blue and gold beads in the jar? Okay, so we will find the confidence interval for blue and yellow beads in the jar as far as, is it percents? No, it says actual amount. Interval for blue and yellow beads in the jar as far as amounts go. Alright, well, let's figure this out. Okay, that's my statement. Okay, then we have to do a do part. Okay, and so we're going to go like this. We're going to write a do part, or a plan. So we made a statement, now we're a plan. This is our random test. Our normal and independent. So is it random? Did I take a random sample? Yes. I would say yes, the beads were not in any order. This is, I mean, I'm sure some of you guys could threaten me with some things, but I would have to say, looking at the bottom, it's random beads on the bottom, right? Okay? Indy, that's short for independent, right? Is this less than 10% of the population? All right, and I have 130. There are 13,000. So, independent, yes. The sample size of beads is less than 10% of the entire jar. Okay? And then lastly, normal. Now remember, my normal test for proportions is 10 successes, 10 failures. I had 36 cool ones, and I had 94 bad ones. So I'll say yes, normal, because we had more than 10 success and 10 fails with 36 success and 94 fails. Alright, now here comes the fun part. Alright, and we're going to have to move pretty fast here. Okay, we're going to get to this do part. Alright, here's the fun part. What's my best guess? Percent that's in the jar. I would say it is 0.2769. That's my best guess. Right? It's not going to be right on. Right? Could be a little less, could be a little more. That's just what the bottom shows me, right? About 26, almost 28%. So I'm going to add some wings onto this bad boy. Plus and minus. Critical value. How much do I want to be? 95% accurate. Now remember, we're not using 2 anymore. We've grown up. We are not lallygagging. 95% is 1.96. Alright? And then my standard deviation. And you might say, I don't know my standard deviation. Well, ladies and gentlemen, if you click through your inference, sorry, I'll take you through. Where is it? There it is, right here. Sample proportion. How do we find a standard deviation? There, now you remember, right? Okay, I'm going to have to pause, put that sucker in, and we'll figure it out, alright? So, bear with me. I'm going to put the square root, and we'll be right back. Alright, so I plugged in the standard deviation formula right over here. That gave me 0.2769 plus or minus 0.0769. And remember, the whole thing asked how many beads. Now, this is just a percent. So I multiplied that by the beads in the box, and I got this interval. I would write a conclusion and be done. I'll see you guys.